Hey, if you're thinking about getting a job in cloud, you gotta know the difference between public and private cloud. As more organizations consider migrating to the cloud, they have to figure out if they want to host their own private cloud or should they use a public cloud solution. In this video, I'll show you the key factors to consider to make an intelligent cloud migration choice. I will also go over some real-world examples of the pros and cons for public cloud versus private cloud configurations. By the end of this breakdown, you'll gain a real-world understanding of which concepts go into the thought process of choosing a public cloud solution versus a private cloud solution. I'll even go over a third option that provides a balance of flexibility and control. Make sure to take note because this type of info works great during interviews if you're looking to get into a cloud job. Before I begin, hit subscribe and the notification bell so you can get the latest updates from V.I.P Tech Club. Okay, so what is the public cloud? You can think of the public cloud as a selection of computing services offered by third-party cloud service providers over the public internet. The most popular cloud service providers are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. The services are available to anyone who wants to use or purchase them. When sold, customers pay only for what they use. This includes things like CPU cycles, storage, or network bandwidth consumed. Now here's one thing to keep in mind. Let's say you want to use Amazon Web Services to set up a virtual machine to host a website. If you go this route, your virtual machine will exist in a shared space. Other AWS customers will have their virtual machine on the same physical hardware that your VM uses. Public clouds are popular because they put your organization in a position where they can easily grow to meet traffic demands in a cost-effective way, all while allowing applications to be accessed from anywhere. Some companies might be hesitant to migrate to a public cloud solution due to a variety of reasons such as security concerns or potential compliance issues. When it comes to security concerns, one primary issue is data loss. The risk associated with transferring large volumes of organizational data include technical issues and human errors that may result in data being lost or corrupted. One culprit of data loss is hardware failure. For instance, when a server or storage drive doesn't work correctly, this can disrupt the information transfer and cause data corruption or loss. Human error can manifest as misconfigured migration settings and unintentional deletions or misunderstood objectives that can lead to data loss or corruption. To mitigate these risks, you can use a checklist designed to prevent data loss during cloud migration. Here's some things to keep in mind for the checklist. Before you take your data to the cloud, it's important to understand what you're dealing with. Take a close look at your information and sort it out. What's really important? What's not so crucial? Answering questions like this will help you prioritize and keep your most valuable info safe during the move. Add backups to your migration checklist. Make sure you have your safety net. Before you start moving your data, make sure you've got a good backup plan in place. This way, if something unexpected happens, you're covered. It's also a good idea to check if your current backups work and maybe create extra backups for an added layer of protection. Couple of final points for the checklist. Make sure everything runs smoothly. Test the migration on a small scale first, like a practice round. This helps find any issues and make sure your data stays in good shape. Keep a rollback strategy in your back pocket in case something goes wrong too. Lastly, document everything. Write down each step, how things were set up, and where the data is going. Your notes will eventually become your guidebook for solving problems and keeping track of what happened during and after the move. But remember what I said? In addition to data loss, cloud migration hesitancy can be due to potential compliance issues. Imagine if you work for a healthcare provider called V.I.P Tech Health. What if V.I.P Tech Health was a regional healthcare provider looking to enhance its efficiency by migrating patient data and operations to a public cloud environment? Given the sensitive nature of healthcare data, your job as a cloud migration architect is to make sure the organization meticulously adheres to industry standards such as HIPAA. In this fictional scenario, V.I.P Tech Health deals with electronic protected health information, otherwise known as EPHI. This means compliance with HIPAA is non-negotiable. During the migration process, the organization should focus on using data encryption measures to make sure patient data is transmitted and stored securely. Stringent access controls should be configured to ensure that only authorized personnel can access patient records. Audit logs need to be in play too. HIPAA compliance requires that logs be maintained so they can be used in a forensic manner in case there's a data breach. So that's the deal with the public cloud, but what about the private cloud? The private cloud is a cloud computing environment dedicated to a single organization. In a private cloud, all resources are isolated and in the control of one organization. It can also be referred to as the corporate cloud. A corporate cloud can be hosted either at an organization's own data center or at a third-party private cloud provider who offers private cloud hosting services. Migrating to a private cloud solution can help an organization manage their infrastructure with as much control as a traditional on-premise setup. Building a private cloud makes it possible for all enterprises, even those in highly regulated industries, to avail themselves of many of the benefits of cloud computing without sacrificing security, control, and customization. Here are some specific reasons why organizations may opt for a private cloud solution. Private cloud customers are free to purchase the hardware and software they prefer. Some of these choices may not be available in a public cloud scenario. In a public cloud setup, customers do not have control over the physical servers that host their applications and data. The cloud provider manages the server hardware while customers interact with virtualized instances. But in a private cloud setup, organizations can choose and manage their physical server hardware, enabling them to optimize configurations based on their specific requirements. For example, efficient GPU utilization is essential for faster model training in machine learning projects. The preferred GPU hardware and settings for machine learning applications may not be available in a public cloud scenario. This can impact a deep learning artificial intelligence project. Without fine-tuning settings such as GPU utilization, memory access, and power usage, you might miss out on a faster training schedule for your deep learning AI project. Also, private clouds are typically owned by the organization. That means no sharing of infrastructure with other organizations. This isolated environment provides different levels of security through dedicated private servers. Considering the various compliance requirements of different data protection laws, a private cloud provides enhanced security compared to a public cloud solution due to infrastructure isolation. Now I want to talk to you about the shared responsibility model and how this comes into play for this discussion. The shared responsibility model is a security and compliance framework that outlines the responsibilities of cloud service providers and customers for securing every aspect of the cloud environment. That includes hardware, infrastructure, endpoints, data configuration, settings, operating systems, network controls, and access rights. In its simplest terms, the shared responsibility model dictates that the cloud provider, such as Amazon Web Service, must monitor and respond to security threats related to the cloud itself and its underlying infrastructure. Meanwhile, end users, including individuals and companies, are responsible for protecting data and other assets they store in any cloud environment. Unfortunately, this notion of shared responsibility can be misunderstood, leading to the assumption that cloud workloads, as well as any applications, data, or activity associated with them, are fully protected by the cloud provider. This can result in users unknowingly running workloads in a public cloud that are not fully protected, making them vulnerable to attacks that target the operating system, data, or applications. When discussing the shared responsibility model, it's important to talk about the three main cloud service models and the impact on what is a shared responsibility. The three main cloud service model is software as a service, infrastructure as a service, and platform as a service. Each of these cloud delivery models are subject to the concept of shared responsibility. However, ownership of security tasks vary depending on the delivery model in use. Let's talk about the software as a service model. Software as a service, otherwise known as SaaS, is a delivery model where the organization that owns the software decides to host the application in the cloud so that it can be used by a subscriber. An example of SaaS technology is Salesforce. Salesforce is a leading customer relationship management platform that operates on the SaaS model. It provides organizations with cloud-based tools and applications to manage various aspects of customer interactions, sales, marketing, and servicing. In this model, the cloud service provider is responsible for application security as well as its maintenance and management. Platform as a service is a platform delivery model that can be purchased and used to develop, run, and manage applications. In the public cloud platform model, the cloud service vendor provides both the hardware and software generally used by application developers. The cloud service provider is also responsible for security of the platform and its infrastructure. Microsoft Azure App Service is a platform as a service offering that enables developers to build, deploy, and scale web apps and APIs quickly. It abstracts the underlying infrastructure, allowing developers to focus on application development and logic without the need to manage servers. One example of infrastructure management that developers don't have to worry about with a PaaS solution is updates. In this example, Microsoft handles the underlying infrastructure maintenance, ensuring that servers are patched and updated without developer intervention. By providing a fully managed platform that handles technical details behind the scenes, developers can concentrate on creating, launching, and expanding applications without getting bogged down by complex infrastructure issues. Speaking of infrastructure, infrastructure as a service is a delivery model where a cloud service vendor provides a wide range of compute resources, such as virtualized servers, storage, and networking equipment over the internet. In this model, the business is responsible for maintaining security of anything they own or install on the cloud infrastructure, such as the operating system, applications, middleware, containers, workloads, data, and even code. Amazon EC2, part of Amazon Web Service, is a prominent example of infrastructure as a service. It provides scalable virtual computing resources in the cloud, allowing users to run virtual servers, known as instances, with various operating systems and applications. Users can scale up or down by adding or removing virtual machines based on demand. This scalability ensures optimal performance during varying workloads. When comparing infrastructure as a service to platform as a service, it's essential to understand that security responsibilities shift from the cloud service provider, like AWS or Google Cloud Platform, to the customer. For example, with IaaS, users have more control over network configurations, including setting up firewalls, defining access controls, and managing network traffic. While this flexibility offers customization, it also implies increased responsibilities for users to secure the network infrastructure. When it comes to operating system security, users are responsible for securing the OS running on the virtual machines. That means regular updates, ensuring proper configurations, and implementing security measures at the OS level. While infrastructure as a service provides the foundation, users are still responsible for securing the applications they deploy on virtual machines. So let's say you installed a web server software on your cloud-based VM. As the customer, you're responsible for keeping the OS safe by applying updates, making sure the web server is configured securely, and managing who has access to the server. Now let's talk about the security responsibilities in a private cloud setup. In a private cloud setup, customers take on more security responsibilities for the infrastructure, a shift from the shared responsibility model commonly seen in public clouds. First, customers must take charge of network security, having direct control over firewalls, routers, network segmentation, and everything else that comes with the network configuration in a private cloud. Also, the responsibility for physical security measures, such as securing data centers, controlling access, implementing surveillance, now rests squarely on the shoulders of the customer. So we talked about public, we talked about private, we talked about the different security responsibilities in both scenarios. But for a lot of organizations, there's a third option at play. A hybrid cloud approach is one of the most common infrastructure setups today. Many organizations today adopt a hybrid cloud approach, combining different infrastructure settings. This choice frequently arises during cloud migrations, allowing organizations to transition applications and data gradually and systematically. Let's role play again. V.I.P. Tech Logistics is a well-established logistics firm at a crossroads in modernizing its IT infrastructure. Recognizing the potential of the cloud, the leadership at V.I.P. Tech Logistics aims to optimize operations without disrupting their critical logistics workflow. In the quest for a solution, they choose the hybrid cloud model for its gradual and controlled migration capabilities. V.I.P. Tech starts by moving non-mission critical applications to the public cloud, ensuring minimal impact on their day-to-day logistic operations. This approach allows them to dip their toes into the cloud space without risking the integrity of the core business functions. As V.I.P. Tech Logistics continues moving to the cloud, they experience increased efficiency, lower expenses, and better scalability. Encouraged by these positive outcomes, they gradually transfer more tasks to the public cloud, benefiting from its adaptable resources. However, recognizing the sensitivity of certain processes, V.I.P. Tech Logistics may choose to retain some critical applications on their on-premise infrastructure. This deliberate decision ensures that essential operations remain under their direct control while benefiting from the business advantage of using cloud services. The hybrid cloud model allows an organization to modernize their IT landscape at their own pace, ensuring a smooth transition to the cloud era while safeguarding the reliability of their day-to-day operations. If you got value out of this episode, subscribe to this channel and please share this episode with someone who will benefit from it. I appreciate your time and see you in the next one. And remember, success is a choice.